Okay, so here's kind of like the lesson preview now that we got the opener out of the way. In today's lesson, you're going to focus on the highlighted goals, which are to write inequalities in one and two variables to represent problem situations. And you're going to be able to graph solutions to linear inequalities in two variables on a coordinate plane, which is, we touched a little bit about that on the opener with the coordinate plane. So let's take a look. Here's the core activity. That's where we're going to begin. In this topic so far, you have been working with situations that can be modeled by inequalities in one variable. So you've done that before in previous lessons. Some situations require more than one variable to accurately be able to describe them. Consider the following situation. So here we're going to take a look at a situation that requires more than one variable. Okay, so more than one letter, basically. Suppose you and some friends go to the movies and buy some snacks. Okay, here's your snacks. There's your little picture of them. The snack bar charges $2 for a box of candy. Okay, like these jellies right here. $2 for that box of candy. And $6 for the combo. $6 for the combo. The combo is basically your medium drink and your popcorn. So you're going to work in a little bit and kind of try to create an equality for this situation. Okay, let's look at the next slide here, and it'll kind of guide us for how to do that. So to start us off, we need to be able to write an expression that represents the total amount you could spend at the snack bar on candies and combos. So let me kind of get you started. I'm going to pop this up over here. We can write on this and kind of show you what's going on here. So we need two variables just to use the basic variables that we usually use. We're going to go with X and Y. That's kind of, let's see, let me delete that. All right, we're going to go with X and Y. So what do they represent? Well, we have two different things here. We have candy. X can be for candy. We'll just use that one. So X represents the number of candies. And Y will represent the number of combos. Okay, so we have our two variables. Now, how much do they cost? Well, they told us earlier that the candies cost $2 per box. And the combos cost $6 per combo, which includes a drink and a popcorn. Okay, so that's kind of how we need to get started, and we need to be able to write. An expression that will sort of give us a final cost for the stuff that we buy. So remember the keywords before that we used to use or to write out like slope intercept form. When you saw the slope, you were looking for keywords like per, every, each. So in this case, it's happening again. You got the per or every or each. Those are keywords that tell you to do what? Those words tell you to multiply. So we're going to be multiplying $2 per box of candy. Well, what represents candy? Candy is represented by the letter X. So we can start off our equation like this. Not equation, sorry, our expression. We can go 2 times the number of candies that we buy. Candy boxes. So $2 per box. Plus, so we're going to be adding our total cost together, $6 per combo. So $6 times Y, because Y represents the combos. So this right here is how we're going to get started to write this inequality. But first we can start off with an expression like this. Now let's check our work to see if it actually makes sense. Okay, if X represents the number of boxes of candy purchased and Y represents the number of combos purchased, then the expression can be the following. 2x plus 6y. That's exactly what we wrote. And now we're going to introduce a restriction to this, which is going to kind of pave the way for the inequality. So check out the rest of the story. Suppose that your aunt is paying for your trip to the movies. The only spending restriction you have is you must bring her some change from the money that she gave you. So you got to bring something back home. Got to have some change left over. After buying the tickets, you have $12 left for your snacks. Okay, that includes your candy and your combos. So you have $12 left for that. Use your cost expression. Okay, that's the one that we just came up with, the 2x plus 6y. from the previous page, to write an inequality that indicates you would get change from your snack purchase. So if we go back to this, okay, we had 2x plus 6y. Let me use a different color. 2x plus 6y. Now we want to have some money left, but we only have $12 left to spend on snacks. So we want this cost over here to be less than 12. We cannot do an equal to, because if we do an equal to, we would spend all the $12. Okay, we could equal up to 12 and we would have no money left. So whatever we spend on snacks and candy, okay, and combos, has to be less than $12, which basically is going to guarantee that we have some change left over to give back to our aunt. Okay, so that's kind of it right there. This is your inequality that we're going to be using, and I'll see you guys in the next video.